Okay, we will try to understand multi-model endpoints. So why we use multi-model endpoint is because they are scalable and cost-effective because we are deploying large number of models into a single endpoint and they are using same group of resources and a same container to serve all the models. So this is reducing the cost by improving utilization as compared to single model endpoint. And this is the diagram which is showing exactly like the dedicated endpoint. That is like for each endpoint, we have separate instance, and on those separate instance, we have one model. So if we have to deploy 10 model, so we need 10 endpoints, and those 10 endpoints will be having 10 instances. Whereas in multi-model, we just need one endpoint, one instance, and we are good to serve for 10 models. So this is how we have the model serving. Now, multi-model endpoints are good for hosting a large number of models that use same framework on a shared container. What it means is, let's say we have scikit-learn uh, ecosystem where we are using the algorithm to make a model to learn the pattern. So if that is same, that underlying ecosystem is same, then we can use multi-model endpoint. And let's say if our framework is different in the sense, let's say we have a TensorFlow framework, then for that case, we use a different endpoint. So it will serve only the same kind of framework models. If you have a mix of frequently and infrequently accessed model, then also multi-model endpoint actually helps because it saves cost. So we're already aware that our model is accessed very frequently or less frequently. We are not sure about the model invocation request. Then we are good with this because it is using the endpoint resources more. Your application should be tolerant for occasional cold start related latencies. So if the model is being used less, then we have to be sure like we are good with cold start latency. So if that is the scenario, then we can go for multi-modal endpoint. Although multi-modal endpoint support both model categories, if we have CPU-based model or GPU-based model, so we can serve. The difference is that GPU-based model would be in one endpoint, and CPU-based model that could be 100 or 1,000 that could be on different endpoint. By using GPU-backed model, we can lower the deployment cost through increased usage of endpoint because endpoint resources, the compute and storage underlying resources are being used to the fullest when we have multiple models and also enable time sharing for memory resources across your model. So there is also a memory, like we have compute resources, we have storage resources, we have memory resources. So memory resources are also being used in a shared mm, concept. Shared concept means that is like if we have the request for the model, then that model will be living in the memory, and the unused model will get evicted from the memory based on the current invocation request. When this is the case, multi-model endpoints can effectively use instance across all models. So the instance usage would be effective, right? Because we have multiple instances. So the resources are being used effectively. If you have the model that have significantly higher transaction, then what is the scenario? When we use dedicated endpoint, that is when we are not okay with the higher latency and our transaction per second or the request per second is higher. So in that case, we need a dedicated endpoint. We cannot go for multi-model endpoint. And what are the features we have for multimodal endpoint? One is the private link. What I mean by private link in the VPC, that is like when a model request a model from S3 bucket. So the request travel um, through the public network that is not secure. So we have the endpoint, which is using the AWS dedicated tunnel. So our traffic is not exposing to the internet. This is the security. And second is the auto scaling. So based on the auto scaling policies, our instances will get increased or decreased. So according to the traffic pattern. Then we have serial inference pipeline. Serial inference pipeline is a kind of implementation, I would say, a concept here, a framework that is like we will use multi-container. What I mean by multi-container is like the pre-container, post-container, and in the middle we'll be having the predict container, and that predict container will be having all the models which are needed to serve the request. So the model language is different and the web language is different. So it will convert the request pre and post. For example, our web server or the browser web understand JSON. So after predicting, it will convert the response in the JSON to serve to the browser. And the another feature is for A/B testing. Also, we can use multi-model. And to create multi-model endpoint, either we can use Python or we can use console. So it totally depends on the choice. CPU based multi-model endpoints we have, and we also can create custom built container by integrating multi-model server library. What does that mean? Is in the multi-model endpoint, we need not to build our image. If we are if we don't need more control, then we can use the built-in container, and we just need to pass the path where our models are being stored for this multi-model endpoint. And in this multi-model endpoint hosting option, we have like how this actually work. This actually work based on used, unused model, and accordingly it will load or unload the model from the storage volume or from the container's memory. And sample notebooks for multi-model endpoints. Then for multi-model endpoints, we have CPU-based, GPU-based models, right? And we have the supported algorithms for each framework that could be scikit-learn or TensorFlow, and we have instance that could be CPU or GPU based for serving the multi-model endpoint. Instance recommendation for multi-model endpoint deployment. Um, Instance recommendation is like in the lower environment, we have a recommender container that will actually test the load, like how many requests per second or a model can handle. And according to the traffic we receive, the actual traffic we receive, we can decide the compute resources. And then we create a multi-model endpoint, then we invoke the endpoint based on the header in the request. And we can also add or remove the model. So let's say we are already serving 150 model from this multi-model endpoint. We wanted to add two more models. So we can add those two model in the S3 bucket. We need not to make any changes in the endpoint configuration. Then same, we can also build our own container. Like we can use the built-in container also. And if we want more control, then we can go for our own container also. And multi-model security is like we are restricting our our flow should travel within our private network. It should not travel on the public network for the security point of view. CloudWatch metrics for multi-model endpoint deployment. If we want to monitor our metrics, then we can use CloudWatch. And and the caching behavior. So caching behavior actually depends on frequent or infrequent invocation of the request. Based on this, it dynamically um, download or cache the model in the memory. And we have auto scaling policies. So if the traffic pattern is high, in that case, we will require more number of instances. So they will be automatically taken care by this endpoint configuration where we'll be defining those scaling policies. How multi-model endpoint works. So how it actually works. So multi-model endpoint hosted on this multi-model endpoint in the container memory. What I mean by this, so it is like the container which we have. So that container needs to load the model into its memory. Only then that container will process the request, right? As per the request header for the model. And instead of downloading all the models from the S3 bucket to the container when you create the endpoint. So when we create the endpoint, it will not download all the model to the instance or from instance to the container. What it does, it dynamically loads and caches when the request invoke them. So what when SageMaker receives an invocation request, so how the request actually flows. First, it will route the request to the instance behind the endpoint. So behind the endpoint means in the configuration of the endpoint, we define the instance, the compute resources, storage resources, memory resources. So uh, those instances will receive the request. Then instance will download model from S3 bucket to the instance storage volume. Right. Like as per the request header, it will download that particular model from S3 to the instance storage volume. Now the model is an instance storage volume, not the container memory, right? Then third step, what it will do, it will load the model to the container memory. And that depends on what type of framework we are using. Either we are using scikit-learn or TensorFlow. According to that, we'll be having the CPU or GPU based resources. Then if the model is already loaded in the container memory, so invocation is faster because SageMaker doesn't need to download and load it again. SageMaker continues to route request or model to the instance where the model is already loaded. Let's say the model is already loaded and a user has requested a second ago, and again, same model request is coming. So it will continue to serve from that loaded model. So the invocation is faster there. However, if the model receives many invocation requests and there are additional instances, so the request will be sent to other instance also. So then additional instance, what it will do to accommodate the traffic, it will load if the model isn't already loaded in the second instance, then it will download into the instance storage volume and then it will load into the container memory. Right. When an instance memory utilization is high, because that could be also a scenario, the model that it is storing the keep on storing the models, right? So the utilization, memory utilization would be high because they're storing the model in the memory. So based on the model usage, uh, let's say it needs to load another model into the memory. So it will unload the unused model from the instance container to ensure there is enough memory to load the model for which the request is currently. Model that are unloaded that will remain on the instance storage volume because they are just unloaded from the container memory, not from the instance storage volume. That can be loaded into the container memory later without being downloaded from the S3 bucket if the request comes. And if the instance storage volume reaches its capacity, let's say the instance storage volume has reached its limit. In that case, what it will do, based on our current invocation, it will delete unused model from the storage volume and download the model for which the request is currently. And to delete the model, so first we need to stop sending the request and then we can delete it from S3 bucket. SageMaker provides multi-model endpoint capability in serving container. So it is providing the capability for serving container. Adding model to and deleting them from a multi-model endpoint doesn't require updating the endpoint itself. So we are not updating the endpoint. When we want to add or delete the model, we just need to upload it to S3 bucket and it will automatically invoke based on the request in the header. When you update a multi-model endpoint, initial invocation request on the endpoint might experience higher latencies as smart routing in multi-model endpoint adapt to your traffic pattern. What does that mean? This means like it dynamically um, load unload model based on the traffic pattern. So if initial request come, then it will take higher time because it will download, then it will load to the container memory, right? But if the model is already in the container memory, in that case, the invocation would be faster. And these are some sample notebooks. Sample notebook like we have multi-model endpoint for CPU-based instances. This is just a sample notebook. And this is a sample notebook that is for creating custom container. Like we can use built-in container also, or if we want more control, and if there is a requirement where we need some customization, then we can go for this. For multi-model endpoint, like we can also use GPU-based instances. That is, let's say, TensorFlow framework. And for those frameworks, we need GPU-based resources. So this is all about uh, multi-model, I would say, hosting option we have and what are the scenario where we use it, what are its feature, how it works. Okay, today we will try to understand about multi-model endpoint. Um, we have this is one of the hosting option and how this actually works. But before this, we want to understand what are its features and in what scenarios we use multi-model endpoint and in what scenarios we use dedicated endpoint. So let's say we have 1,000 or maybe 800 models that works on scikit-learn framework. So those number of models we can deploy in a single container. That feature is available with multi-model endpoint. And we have the similar size of each model and also the latency requirement is also acceptable for each model. Then we can go for multi-model endpoint because we are saving on the um, deployment overhead and on the endpoint resource utilization also. When we go for dedicated on endpoint is when our business require more number of requests per second and the latency requirement is it should be low, not high. So in that case, we can go for dedicated endpoint. Um, and now this is like in what scenarios we will select which hosting type. Now, what are the features it provides? So first feature it provide is the auto scaling. So we can configure auto scaling policies in the multi-model endpoint, and we can also have a private we can say endpoint so that our traffic from S3 to the container is flowing in the dedicated tunnel, not on public tunnel, because there are some security risks when our data or the request travel over internet. And third is the auto scaling is covered, the endpoint is covered. We have one more that is called a concept that is inference pipeline. So when we want to use multiple container in multi-model endpoint, so we can leverage the pipeline inside the multi-model endpoint that is the pre-container and the post-container, and in the middle, which is predicting the request, that would be our container, which is having all the models which uh, it needs to serve. Let's say 700, 800, or 100. It depends on the model which we want to deploy as per our requirement. So this is like its feature, and now we will try to understand how exactly it works. So how it works is, let's say there is initial request which comes. So what happens? SageMaker route the request to to the instance which we have defined in the endpoint configuration. And from the instance, the request goes to the next step, that is to download the model in from the S3 bucket for which the request header uh, has in its payload. So that particular model would be downloaded from S3 bucket to the instance volume storage, and from the volume storage, the model would load into the container memory, and from there the request will process and get served to the user. This is one. As we have discussed, there could be like thousands of models. So uh, it is not downloaded at once. It is actually working in a way whenever the request comes to the SageMaker, then it download and load into the container memory. Let's say if the request comes and that is already in the container memory, so it would be served faster because that model is already in the container memory. But what if the container memory reached its threshold, right? So what it automatically does, it remove or it unload the unused model from container memory and just deliver the model for which the request currently is coming. And second scenario, let's say the instance itself reach the threshold or it's hit its capacity, then what will happen? It will remove that model from the instance volume to have a space for the request for which we need to download the model from S3 bucket. So this is how intelligently it process or it cache the model in the container memory or in the instance storage volume. So this is how it works, and it depends on the framework. So let's say we have framework, then it's most likely CPU based resources we are using, and if we have TensorFlow framework, then we likely to use GPU based resources. And the container that is also built in SageMaker. But in case we want more control and if we have more customizations which we have to do as per our organization, then we can also build our container and then use that container in our SageMaker multi-model endpoint. So this is how multi-model endpoint works.